Hi friends, here in this video I'll be explaining the problem on simple machines. So let's get started. Now here is a question. Whatever is given here, I'll write that in the form of data first. So a machine has a VR, that is velocity ratio of 50. A load of 6 kilonewton is lifted. So load is denoted by capital W. It is 6 kilonewton. So 6 into 10 raised to 3 Newton. Lifted by an effort of 300 Newton. Effort is denoted by capital P. Calculate the efficiency and the effort lost in friction. So effort lost in friction is denoted by P suffix F. So this is the question in front of us. Now as we can see in this question, load and effort both are given, so we can get mechanical advantage, and velocity ratio is also there, so efficiency can be calculated. So I'll start with the solution part. Since the efficiency of the machine is given by, it is output upon input, and output is load into distance moved by load, which is x distance. Similarly, input is effort into the distance moved by effort, which is y. So W upon P. Here we have y. X would be shifted into this denominator. Load upon effort is called as the mechanical advantage, whereas y upon x is called as velocity ratio. So therefore efficiency would be W upon P into VR. Now just putting the values here. W is given 6 into 10 raised to 3. Effort P is 300 and VR is 50. So from this I'll get the answer of efficiency, and it comes out to be 0.4 or 40%. So that's the first answer. Next, we have to also find the effort lost in friction. Since the effort lost in friction is given by P suffix F, and that is actual effort minus ideal effort. So therefore P suffix F, actual effort is denoted by P, ideal effort is P suffix I. Now keeping this as the first equation, actual effort is given in the problem, it is 300 Newton. Ideal effort is what we have to find out, and for that I'll explain here that since ideal effort will be there in a machine which is ideal means efficiency of that machine would be 100%, or if a number it would be 1. So therefore the efficiency is nothing but MA upon VR, and as the efficiency is 1, so we can say MA is equal to VR. MA is equal to VR because the efficiency is 1. Now MA is W by P is equal to VR. Now since we require the formula of ideal effort, I'll add suffix I here for the effort. So the ideal effort is W upon VR. So therefore ideal effort is W upon VR. Now W value is there with us, it is 6 into 10 raised to 3. The velocity ratio is given as 50. So ideal effort would be 120 Newton. Now ideal effort and actual effort both are known, so I'll put the actual effort and ideal effort in the first equation. So I'm going to get the value of load lost, the effort lost in friction. The actual effort is given as 300, ideal effort is 120. So the effort lost in friction comes out to be 180 newtons. That's the second answer. So it was a simple problem regarding simple machines in which the efficiency and the effort lost in friction was asked, and we had solved the problem. At the end, if you all find my videos helpful, you all can like, share, comment and subscribe our channel and share it amongst your family and friends. Thanks for watching.